In this short video, we're going to look at how and where you organise and declare your standard compositional data. Before we actually launch the software to do this, let's go over some notes. Now, all of the data is stored in a single database called standard.mdb. Now, this can hold over 32,000 standards, but for reasons I'll explain later, if you can keep below 2,000 if possible, that's helpful. Each standard has a unique identifier number which can either be assigned manually or automatically, e.g. the next available number. Now, it's recommended that you group standards together. So for example, all standards in a given sample mount are grouped together. And it helps if you can leave gaps between these groups of numbers. So for example, you might allocate all the 100 numbers to a silicate standard block and all the 200s for an oxide standard block, etc. This makes identifying standards in the same block a lot easier. It also means that you can allocate a block of numbers to temporary users or people who have temporary standards, so you can easily identify which are their standards and overwrite them after they've finished working on them. Now, there's several ways to launch standard.exe. You can either do it from a desktop shortcut, from the Probe Software Start menu folder, or you can dig all the way down to the source folder, which is normally on the C drive, and this will be in Program Files x86, Probe Software, Probe for EPMA. Or if you've already got Probe for EPMA running, you can select the standard menu item and then the standards database submenu item. The very first time you launch standard.exe, there will already be some standards declared. This is demonstration data which is used for training purposes and also for people to test the software. You will need to overwrite this with your own set of standard details because obviously it won't match your own standards. To do this, you go to File, New, and you accept the suggested file name standard.mdb and press Save, and then select Yes to confirm overwriting the existing demonstration file. And then you can start entering your standard compositional data into the new empty database. Now, I emphasize, you're only overwriting this the very first time you launch standard.exe. Once you've started generating your standard.mdb with your standard data, you'll only be adding to it or modifying it. Now, as we'll see in a minute, you can enter the data as oxide percent or elemental percent, depending on how the data is presented on your certificates of composition, or as an atomic formula composition, which I'll demonstrate later. You can also display the composition as oxide standard or elemental standard, and the choice isn't limited by how the composition was entered, so you could enter it as an oxide percent and display it as an elemental standard and vice versa. And it doesn't limit how the standard is used. All of the data is stored as elemental in the standard.mdb. You can also add descriptive labels, so you can give it a material type, for example silicates, alloys, etc., to help with searching through the minerals and standards. And you can also give it a standard mount name, e.g. the rare earth glasses block. One important thing, everything is stored in this one standard.mdb. Make a copy and back it up, archive it somewhere every time you update it. If you lose this data, it's going to take you a lot of time to re-enter it. So unless you enjoy putting standard compositions in, keep a backup. Now, let's enter some standards. Now, as I said, there's several ways for launching it. I've got a screen shortcut here, but I'll show the other options as well. If we launch an Explorer window, I'll go through the hardest to the easiest. So the hardest is to go to the C drive, to your Program Files x86, Probe Software, Probe for EPMA, scroll down, and there's standard.exe there. You might have it listed in your Start menu, or if you scroll through the Start menu list and go down to Probe Software, there'll be a Probe Software folder there. Again, scroll down and you can launch it from there. Or if you have Probe for EPMA running, you can click on Standard and Standard Database there as well. I'll launch it from the desktop shortcut. Now, the first thing it does is ask you which database you can open. Now, you can see there's already quite a list of databases here. You may not have as long a list as this, but there are some that come as default. For example, the dhz.mdb includes all of the data out of Dear Howie and Zeusman. Whilst you're not going to be using it for this video, if you're doing mineral matching, it's useful to have a very comprehensive database. And in fact, these databases which come with the software are the ones that use the numbers above 2000, which is why it's helpful if you limit your numbers to 2000. Now for this video, I'm going to assume that this is the very first time I'm launching this. So we want to overwrite this standard.mdb. It does actually say standard.mdb. So I'll cancel that and I'll go File, New. And we do want to use standard.mdb because the software requires it to be called that. And we click Save. It'll tell us it already exists and do we want to replace it. Click Confirm to say yes. Then we can enter some descriptive data about the database. I'll leave that as it is. Right, now we have a blank database which we can start entering standards into. And the way we do that is we go Standard, New. Now because there's no standards in here, it automatically gives the first one a number of 1. Now what we actually need is we need some standard data, so let's put that up there. There's some made up numbers. So say for example I didn't want to start at 1, I want to start this block at the 100, so let's start at 100 and call that copper metal. Now the standard name is important to get very descriptive because this is what you're going to see in the list of standards when you're selecting which standards to use. So if you have several copper metals, this is where you would add that this is, for example, the Goodfellows standard, or this is a good one or a small one or whatever. The description is just something you can look up later, so we'll just call it Goodfellows. Now, as I said, you can enter the composition as oxide percent or elemental percent and display the composition as oxide or elemental. Now we've got a pure metal, so that's in elemental percent, so let's select elemental percent and we'll select it as display it as elemental standard as well. To enter the compositional data, you select the first empty cell in the channel and it'll bring up the element properties box. Now you can either select from a drop down list or you can just type in that it's copper. You don't have to worry about the X-ray or the cations and oxygens because we're putting this as elemental, and it's 100%. Okay, I've got a total of 100%, and we can select OK, and it then gives us a summary of that data. So let's put a new standard in, but let's do it as a different way. So let's select New, we want this one to be 101, and this is an Amelia Albite. And we'll just say that's a natural albite and it's from VA, USA. Now, this time the compositional data has been given as oxides, so we select oxide percent to put it in, and we'll just display it as the oxide as well. That makes it easier. Okay, so we select the element as before, silicon. Now this time we need to pay attention to the cations and oxygens. It'll suggest what it thinks the cation to oxygen ratio is. So in this case, one silicon to 2 oxygens, SiO2, which is correct. And then we put in that it's 68.710 weight percent oxide. And we click OK, and that's the position. But it's already calculated what the elemental percent is. And let's go through and add the other elements. So aluminium, Al2O3, and this is 19.5. Sodium, 11.700. And finally potassium is 0.1. Okay, and we can check 100.010, total oxide percent 010. Now, the thing to remember, although we've entered the composition as oxide percent, this is being stored as elemental. And we need to remember that we need to add oxygen as an individual element. And the way we get what number that is, because obviously it's not given in here, is we look at the total oxygen from the cations, which has been calculated. So that's 48.810. Okay. And now the elemental and oxide percents add up. And we select OK. And again, it gives us a summary. Now, let's add a third one. So let's call this 102. And let's call it nickel sulfide. And this is synthetic. And it's stoichiometric. Now, stoichiometric means that it's exactly NiS, 1 nickel to 1 sulfur. So we have an option here. We can either enter the weight percent, or we can enter this as an atomic formula composition. So if we select there, and we select, just type in NiS, so 1 nickel, 1 sulfur, it'll automatically put the data in, and it confirms that yes, the composition data we have is stoichiometric. Oh, yeah, sorry, my mistake. Elemental percent. Okay. And that's how we add data. Now, if we've made a mistake in any of these, we can go to Standard, Modify, and then we can edit the data for that. And it asks you if you want to save it or modify it. So we say yes. And that's how you store standard data. So you put all your standards in. So I've got all these up to 100. You might start the next standard block with the 200s, etc.